Today we are going to be discussing Thevenin and Norton's theorems, and we are going to describe what the similarities are and what the differences are. So, the purpose of Norton and Thevenin is to take a circuit that looks like the one on screen, and you see here that we have our load resistor, and that load resistor can be any value. And a lot of times when we do Norton and Thevenin questions, like you're going to see on your homework assignment, this is for DC theory level 4, DC theory level 5, you will see that in that there are you'll have a lot of different size load resistors. So instead of us going through and redrawing the circuit, again, going back to first year DC theory, where we had our resistor that was in series, and then these two parallel resistors, and this resistance would be this amount every time, so this would be 12 ohms every time, and this would be 6 ohms every time. But we would have to go through now and change the value of this resistor, this load resistor. We would have to go through and change that every time and go through and solve for all those every time. So instead of doing that, we have our Norton and Thevenin theorems. So they are going to be different. Norton and Thevenin are going to be different in the respect that Norton is going to use a current value and the load resistor is going to be placed in parallel, and Thevenin is going to be where we're going to create a voltage source with a resistor in series. So we're going to solve for both of them, and I'm going to actually kind of do them on the same screen, not to be confusing, but just to give us the concept that it doesn't matter if we do Norton or Thevenin, we're going to get the same response. So it doesn't matter which one you decide to do, you'll get the right answer. So the first thing we're going to do, I'm going to do Thevenin is going to be in red, and Norton is going to be in blue. So we'll start with Thevenin. How to get the Thevenin resistance and the Thevenin voltage is a little bit trickier, but we are looking for a Thevenin voltage and a Thevenin resistance. And on the Norton side, we are looking for a Norton current and a Norton resistance. So what I will start with is how do I solve for my Norton or my Thevenin resistance. And the reason I'm going to start there is because we solve for them the exact same way. And if I go ahead and I just take this loose here, where my load resistor is going to be, if I just take this and act like it does not exist at all, you will see that I have a series circuit. And this is going to be the mind-numbing part. What I'm going to tell you guys to do is don't look at these like they're in series as far as being able to find your Norton and Thevenin resistance values. Treat them, calculate them like they're in parallel. So if we calculate them like they're in parallel, we have our product sum, or you can do product sum, or you can do reciprocal, whichever way you want to do it. But we should get, in this case, 72 over 18, which is going to be 4. We can put that on our calculator too. 12 times 6. We will do our 12 times 6 divided by 18. Gives us a value of 4 ohms. All right, so again, that is the tricky part of both of these, is finding the Thevenin resistance or the Norton resistance. We solve for them the exact same way. All right, and that is by taking those two resistors that we have values for and treating them like they're in parallel. Now that we have done that, this part, the Thevenin part of this, is a little bit more challenging. So the Thevenin part of this is we are now actually going to treat that like it is a series circuit, and we are going to take our R1 plus R2 which is RL and RS. And we get a value of 6 ohms here and 12 ohms here, which is going to give us a total resistance of 18 ohms. And we have a source voltage of 12 volts. What we're trying to find is how much voltage would be dropped on that resistor, because we know that voltage is in parallel. Voltage in parallel is the same. So if we find the voltage to this resistor, how much voltage drop is there, we're going to know how much voltage is dropped across the rest of the way in parallel. So we are going to use our 12 divided by 18. And when we have our 12 divided by 18, we are going to get a value of 0.67, 0.6 repeating. Again, what we're looking for is this value over here, this voltage drop, and that is going to be our Thevenin voltage, whatever we get right here. So we'll go back onto our calculator. We actually have that value still in the calculator. We're going to multiply it by those 12 ohms, and we are going to get a value of 8 volts. So 8 volts is what our Thevenin voltage is going to be. And now I'm going to push that off to the side, and we're going to go ahead and do Norton real quick, because Norton is actually, it's a little bit easier to solve for my Norton current. Basically, to find my Norton current, all I do is I take, as soon as I can get my blue pen to work. There we go. For my Norton current, all I have to do is take this 12 volts and divide it by that 6 ohms. So when I do that, I'm not going to pump the calculator up for that one. 12 divided by 6 is 2 amps. That's all I have to do for my Norton, to solve for my Norton current. So now that we actually have these now that we have these values, I've got my Thevenin voltage of 8 volts and my Thevenin resistance of 4 ohms. Basically what's going to happen is I'm going to have my voltage source here, and and that voltage source is going to be 8 volts. And this is going to be my Thevenin resistor, and this value is always going to be 4 ohms. I'm going to come over here now, and I believe the first question that you're going to have is going to say you've got a 1 ohm load resistor. And what that's going to ask you is, it's going to ask you, with the 1 ohm load resistor, what would be your amount of current flow through that resistor, and then how much power would be consumed by that resistor or by that load. So if I have a 1 ohm resistor in series with my 4 ohm resistor, I will have a voltage drop of 8, or voltage of 8, source voltage of 8, and my R total, which is going to be 5. So I'm going to solve 8 divided by 5, and that is going to give me 1.6 amps. So my 1.6 amps is going to be what my current flow is going to be. So I'm going to erase that, and my 1.6 amps is going to be applied to my load resistor. I've always got to come back to this load resistor. And now I'm just going to do a pure chart. Well, in this case here, because I've got current, so for 1 ohm, my 1 ohm resistor, I've got 1.6 amps. I'm just going to use I squared R. So if I use I squared R for this, I have the 1.6 times 1.6 times my load resistor, which is 1 ohm. So I'm going to have a power consumed in this resistor of 2.56 watts. Then the question typically, that's your first couple of questions, and then the next question will be, okay, now you're going to change that 1 ohm load resistor to a 2 ohm load resistor. So now I'm going to take that resistor of 2 ohms and add it to my resistor of 4 ohms. And that is going to give me an R total of 6 ohms. And I have a source voltage of 8 volts, again, for the source. So I'm going to take my 8 volts and divide it by 6 ohms of total resistance, and that is going to give me 1.3 amps, 1.3 repeating amps. So for 2 ohms, I will have 1.3 repeating amps, and then it's going to ask me how much power is consumed by that resistor. And I'm going to say that value squared, I squared times R, which is 2 ohms for my load resistor, and that's going to give me 3.56 watts. And then the last one we're going to do, we'll talk about, is the next question is going to be basically a 4 ohm resistor. So we're going to do the exact same setup where I've got a 4 ohm resistor. And that means I have got 4 ohms of load resistor, 4 ohms of Thevenin resistance. It's going to give me 8 ohms. I'm not even going to bring the calculator for that one. 8 volts divided by 8 ohms is going to give me 1 amp. And again, my 1 amp now, I squared R, I'm going to have 1 squared, which is 1, times 4. So my 1 amp is going to give me a power consumption of 4 watts. So that's Thevenin. No matter what I do, I've got to add my Thevenin resistor to whatever my load resistor is, figure out how much current is flowing in the circuit, and then put that current through the load resistor. All right, now over to Norton. So that Thevenin in that respect is a little bit easier to most people. It's the solving what my Thevenin voltage is the hard part. So now we're going to come over here and we're going to do Norton. What Norton's setup is now is this means that I have got 2 amps of current flow, and I am now in parallel with that 4 ohm resistor. And over here I have what is my load resistor. So going back to our original 1 ohm load resistor, you can see that I have got my 2 resistor values now, 4 ohms and 1 ohm, and what I'm going to do with those is I'm going to solve for them using, in this case, product sum, because we're using some pretty easy numbers here. So for product sum on this, I have got 4 times 1, which is 4, and 4 plus 1, which is 5. So I'm just going to do 4 divided by 5. And that is going to give me 0.8 ohms. So over here with my 2 amps, if I've got a source voltage that I don't know yet, my total current is 2 amps, but my R total was 0.8 ohms. When I go ahead and multiply up, I get 1.6 volts. So my voltage over here is going to be 1.6. So 1.6 divided by my 1 ohm is going to give me a current flow of 1.6, which is exactly what I had for my 1 ohm resistor in Thevenin. If I do my I squared R again, 1.6 times 1 is going to give me that exact same value because it was still a 1 ohm resistor, still 1.6 amps of current flow. So now the kicker with this one is we actually have to change. Our voltage drop is not going to be the same anymore, and our total resistance is not going to be the same anymore. So we're going to now change that to a 2 ohm resistor. And now doing, again, product sum, I know hopefully that 4 times 2 is 8, divided by 4 plus 2, which is 6, and lo and behold, we've got 1.3 repeating, which is what we got before. And that 1.3 repeating squared, leaving it in the calculator, squaring it and multiplying it by the I squared R, multiplying it by that load resistor of 2 ohms is going to give me 3.56 watts. And now last but not least, we will go ahead and make that a 4 ohm resistor. And I have product sum, so 4 times 4 is 16. And I'm not trying to sound shitty, but if you actually need to multiply the 4 times 4 on your calculator, then knock yourselves out. I'd rather you did that than miss it. So 16 divided by 4 plus 4, which is 8, is going to give me 2 ohms of our total. And my 2 ohms of our total times 2 amps is going to give me 4 volts. And 4 volts divided by 4 ohms is going to give me 1 amp. And my 1 squared is 1 times 4, which is 4. So you can see, and there's, I think that it goes into like 8 amps and 12 amps and 15, or I'm sorry, 8 ohms and 12 ohms and 15 ohms to continue on with the questions. But basically, you know, trade secret, if you figure out which one you want to do, Norton or Thevenin, and you do it properly, you'll be able to do like 15 questions, 16 questions on the homework by just doing the one that you like best.